Okay, one last thing to try to solve, and that has to do with compound interest. We had this formula which gives the accumulated value, A, of a sum of money, P, the principal, after T years at an annual percentage rate of R in decimal form, compounded in times per year. So what we'd like to know is how long does it take for $25,000 to grow to $500,000 at a 9% annual interest rate compounded monthly. Okay, so let's break this down. We actually want to look forward to the future to find out how much time it takes. The $25,000 is our starting amount principal. The $500,000 is what we want to accumulate in the future. That's going to be the future value A. The 9% interest rate is going to tell us about R, but again we have to take 9% as a decimal, which would be 0.9. And then compounded monthly tells us how many times per year it's compounded. That would be n equals 12 times per year. So let's plug that into our formula up above. It looked like 500,000 equals 25,000, 1 plus 0.09 divided by 12, all raised to the 12 times t power. Okay, so after putting all those numbers in, there's only one thing left that's unknown, and that's time t. So we have to solve for t. That's quite a bit to do because of the formula, but it will eventually need logarithms to make it happen. So here's my first step. I'm going to take all this stuff here in the parentheses, and I'm going to go ahead and calculate that. Okay, just because that takes some of the complexity out of things to get started. So when I calculated the stuff in the parentheses, I got 1.0075. That's still raised to the 12t power. Okay, so I'm trying to get down to just the t. I'm trying to get that thing by itself. So first thing I'm going to do is I'm going to divide both sides by the 25,000. Okay. Now 500,000 divided by 25,000 is just 20. And so on the other side, however, I'm getting that out of the way. So 20 is equal to 1.0075 raised to the 12t power. Okay, so now we're kind of narrowing things down so we can get to the t. But here's going to be the way we can solve for t. Now that that 25,000 is out of the way, we can take the natural log, the ln of both sides. And by putting the ln on both sides, using the properties of logarithms allows me to take the 12t and move it out to the front of the ln. So that's going to make it the ln of 20 equals 12t ln 1.0075. So let's figure out how to get now that t by itself. But t is now down here in front of the ln, so at least it's in a better place to solve for. What I'm going to do is I'm going to divide out both sides by 12. Okay, by dividing out the 12, that's going to make it go away here. I can also divide out both sides by the ln of 1.0075. Okay, and then that allows me to get rid of this whole ln thing here as well, leaving just the t as solved for. So what t is going to turn into is ln 20 all over 12 ln 1.0075. That's something we need to use in the calculator, and if I plug this whole thing into the calculator as is and round it to the nearest tenth, I got out 33.4. So that refers to the number of years in this case. So how long will it take? 33.4 years for that money to grow from 25,000 up to 500,000.